Hello everybody. I have had so much fun the last 3 weeks working with you. Today in particular was really good, mixing colors and the water crystal gels and doing the iodine time reaction. We've got one more day and I'm going to show you several what I call sneaky experiments you can do at home. You can do them a lot of places actually, and everything you need, all the materials you can find at home. The first thing we're going to do is the super sneaky expanding straw case. This will probably help out if you get bored when you go to a restaurant. So what you're going to do is take the straw and you're going to push the paper down. And I'm going to start at the bottom pushing down.
Push it down, push it down, push it down.
Push it down. The smaller you can get it, the better. Once I get it about this big, I'm going to pull it off the end. Come on, buddy. All right, I'm going to squeeze a little bit more, just a little bit. So I got it nice and small. Now, let's see what happens when we put a little water on our straw casing. It's alive. All right. Well, that's kind of fun. At least it might kill 30 or 40 seconds the next time you're at a restaurant. This next one is a little more involved and it's a little more exciting. What I'm going to need for this, some water, some dye, a candle, of course a lighter, make sure your parents know that you're doing this, and then a pretty large glass like this. First I'm going to drop in a little bit of food coloring, and I'll stir that around with my handy dandy pipette. And I'm going to pour it onto a pretty large white plate. And white just helps us see exactly what's happening. Next, I'm going to take my little candle and I'm going to put it in the middle of my plate. Then I'm going to light it. Next, I'm going to take my jar and I'm going to slowly put it over the candle. But before I do that, remember, what does a candle need in order to stay lit? Okay, it needs some kind of fuel, which is the wick, and it needs oxygen. But if I put this cup over the candle and we complete the seal by putting it into the water, we're going to cut off the supply of oxygen. Well, let's see what happens. Well, there's still some oxygen in there for the candle to stay lit. But I'm also noticing something about the water inside. Whoop! Wow, when the candle went out, the water really went up high. So what's the science behind this? Well, when we put the cup over the candle and then the candle continued to burn, the air inside of our jar continued to expand. So the water wasn't coming in. But when the candle went out, the temperature of the air inside of the jar decreased. And what happens when air or any kind of gas gets cool? It contracts. So as it contracted, the water from around the edges was sucked up into the jar. Pretty cool. And you can make this an experiment. You could use a different size jar, different size candle. I find that the shorter candles work better. I tried doing it with very long candles and it didn't work very well. Make sure your parents help you with this one. Have some fun. Oh, hi everybody. I didn't know you were there. You might be wondering, what am I doing? Cutting strips of paper. I am not cutting strips of paper. I am making flying fish. And I'm going to show you how as well. You cut a strip of paper. And then you fold it over so the ends meet. Now, on one side, I'm going to cut a little notch halfway through. And on the other one, I'm going to cut a notch on the opposite side, right? Like that. So then, now the two notches are going to face each other when I put the paper together. And there's my fish. When I flick the fish up in the air, it spins really fast. And depending on the way you flip it, will change the direction it goes. We need a little more space here to see the whole thing, but that's the whole idea. And the reason my fish curves one way or the other has to do with something called the Bernoulli principle. And the Bernoulli principle has to do with air pressure and how air pressure is different, how it pushes on an object as it flies through the air. And something that's spinning, one side is going to have higher air pressure than the other. And the area that has a lower air pressure is the direction that the flying fish is going to spin. And this is the same principle for how pitchers throw curveballs. When they get that to spin, one side has high pressure, one has low. And the higher side pressure will push around so that it goes toward the direction of the low pressure. Some of the variables that you can do to change how well or how far your fish flies is, one could be making a longer fish. A little bigger than this one. I didn't put this one together. You could use different type of paper. You can make them big and small. And when you first start out, be patient, because getting the technique to flip it the right way takes some time. Let me show you a few. All right, let me demonstrate a couple of flying fish for you. Here's the very simple one I made in the beginning. Flip it out like that, and you can see it goes to the side. I flip it out this direction, and it goes out that way. A couple of variables. Here's a really thick one. That goes much slower. Here's a really thick one, but I have a very tiny tail on it. That doesn't work very well at all. I think that bigger tail provides more stability. Here's one that I made out of a grocery shopping bag. It's pretty good. Now, if you really want to see something, look at this big guy. I can even use two hands for that one. And here's another one. It's a little more narrow. Let's see if this is different. It's pretty good. And something, when I noticed that when I cut this one, the edges were kind of pushed in. So that could be another variable. If you were to take the edges and push them down, anything that's going to change just the physical property of our flying fish will make it fly differently. And if you're really sneaky, you can make a trap door and have lots of flying fish come flying down on you. We're on to the next activity. This next activity I call sneaky, colorful currents. And all you need is some cold water. I got my reusable ice cubes here. Some warm water. 2 Frappuccino bottles. 2 different colors of dye. And a playing card. I want to use a playing card because it's slippery, and you'll see why that's important in just a minute. I'm going to take my cold water and fill up my jar, or my Frappuccino container. And in the other, I'm going to fill up with warm water at the very top. And I'm going to add a drop of dye. Let's put yellow into the hot water. And we'll put blue into the cold water. That in and of itself is kind of cool to watch. So then I can pick up my warm water. I'll hold that a little bit, flip it over, and you can notice that the top of it's just a little green. I'm going to pour a bit off, and I'm going to add a little more hot water to my yellow, add a little more dye just because more color in our lives is always better. Now this time we're going to put the cold water on top. Something that's cold is going to be more dense than something that's hot, and it's going to sink. So let's try this again. Actually, I'm going to put it on the other side because I'm better with my right hand for lifting. Flip it over. I'm going to scoot it off to the side. Air pressure is holding that up. Put them right on top of each other. Now, well, the cold water made short work of that, didn't it? Drop right down. Now the bottom is still pretty warm, I think because the bottle got really hot. But the one on top is getting warm as well. So that's just another example of a convection current. It's when 2 different forces, 2 different masses of something, or it can be air, it can be water, move around each other because the temperature is different. And that's really why a lot of Earth systems work. Temperature causes things to change. So, there's another one. Let me think. What are we gonna do next? I got it. I want to show you how to make a sneaky static electricity detector. You never know when this is going to come in handy, but it's going to be really cool to see. All you need for this one is kind of a wide mouth jar, a little bit of tin foil, some big scissors, and I've got some small scissors. And you need a paper clip, you need a balloon, and if you're like me, I'm going to use some small pliers because I'm not very good at bending these paper clips. First thing I'm going to do is take my paper clip and make it into a straight line. And use my pliers to make it nice and straight. Whenever you can use a tool to make your life easier, use it. The next thing I'm going to do is take the paper clip, and I'm actually gonna make a metal flying fish. Just like that. But unlike our other flying fish, I'm gonna squeeze that a little bit more, a little bit, make that really cross over. So that I got a little bulb, little wide spot at the top. And then I'm gonna take the legs, I guess I'll just call them legs. I'm gonna squeeze them in a little bit because I wanna make sure that it can fit inside of my jar with plenty of space on each side. Then I'm gonna take my pliers and I'm gonna make a hook pointing up on each end of the paper clip. Just like that. Okay, now that I've got my paper clip hook ready, I'm gonna cut a small piece of cardboard that's gonna fit over the top of the jar. It doesn't have to be perfect, just something that'll stay on there. Now here's where the small sharp scissors come into play. We're gonna poke a little hole right in the middle. And this might be something your mom or dad help you out with, but I wanna make a hole that's just about the same size as the fat part of my paper clip. I'm gonna just use one side. Be really careful. Remember, when you're working with sharp things, always point away from you. And it also helps to, instead of putting a lot of force into it, just wiggle it a little bit. I got my scissors in there. I'm gonna make a little snip. And my paper clip goes right in there, just like that. All right, I can't forget my tin foil, because that's really important. I'm gonna cut 2 pieces of aluminum foil, about 2 inches long and 1/2 inch wide, or about 1.5 centimeters wide and 5 centimeters long. I'm gonna straighten them out, make them nice and smooth. And then I'm gonna poke a little hole in the end of one of them and put it on the end of one of the paper clip hooks. I'm gonna try and flatten it out a bit. I'll do that with the other one. So I've got my 2 pieces of tin foil hanging down just like that. I'm gonna straighten it out a little bit because I like detail. And I'll put it into the jar. All right, well, nothing's happening right now because there's no static electricity around. But let's bring some static electricity in here and see what happens. Mr. Bones, would you mind if I borrowed your balloon? Why, thank you very much. That is awfully nice of you. You've been very patient today. Okay, balloons make great static electricity. I'm gonna take this balloon and mess my hair up more than it already is to make some really good static electricity. And I'm gonna bring that balloon down towards the paper clip, and you'll notice that 2 pieces of tin foil move away from each other. So we're creating a little current in there. The static electricity is going into the paper clip, and the electrons are moving out, causing the tin foil to move. And that is how you make a sneaky static electricity detector. Might come in handy someday. You never know. All right, got one more thing to show you I think you're really gonna like. I have to bend way over for this one so you can see how to make a sneaky laser light show. Now what I have here, block of wood, and I got 5 mirrors. Now this might be something, you probably don't have 5 mirrors like this sitting around, but maybe the next time you're at the dollar store you can get some. And I have modeling clay holding up my mirrors that I use popsicle sticks to make some handles so I could stick them into the modeling clay. And I have little laser light, kind of to use to play with cats or bother your little brother. And I have set these mirrors up so that the laser will bounce from one to another, to the third, to the fourth, to the fifth, and then back at me. And this is one where it definitely helps to have 2 people, because trying to hold the laser and adjust these mirrors has been really hard, but it's been a lot of fun. So I'm going to start by putting my laser on the block and finding the very middle of my first mirror. And then I'm going to take a pencil and draw a line where the laser light sits on the block. So that way I'll always know if I need to adjust something, I'm going to know exactly where that laser light's going to sit, so I don't have to keep doing the first mirror over and over again. So it's bouncing from this one over to this one. Now one way you can track the light by putting your hand in front of it and seeing where it leads, if it doesn't hit right on the mirror. And this one is not. So I can move my laser light around, and I'm seeing it just at the top, and I'm sorry you can't see it because it's this one here. I'm going to take this first mirror and put it down just a little bit so I can adjust the angle so that it's hitting mirror number 2 a little better. Now this is where it'd be nice to have somebody to help out. But I kind of got lucky, because mirror number 2 is hitting on mirror number 3. And you'll see, if you can, the laser light now is on the table right in front of the block. So I need to take mirror number 3 and raise it up. This is actually pretty good to have it on the table, because I can follow the laser light. I can keep adjusting that mirror and watch laser mirror number 3 have it go over to mirror number 4. The other problem with this modeling clay is after you push it down, it kind of relaxes and goes back into the earlier shape. So again, if you got somebody to help you out with this, that's going to be helpful. So I've got it on mirror, not quite, mirror number 4. So you guys get the idea. But you can go try to get as many mirrors as possible. And once you figure out exactly where they go, maybe you could use something a little different than the modeling clay, so it could stay in place a little better. And better yet, have somebody help you out. Because it's always fun to do this stuff with somebody else and see how many mirrors you can get bouncing it around. Now, the farther away the mirrors are, the more challenging it would get. You can also use bigger mirrors, and that would help. But challenging yourself is what it's all about, and that's how you learn. Year 1 of the Castle Hill Virtual Science Camp, I think, is over. And I'll be seeing most of you in about 6.5 weeks. So enjoy the rest of your summer, stay safe, and I'll take care. Bye-bye, everyone.